Okay, lesson number 3. So what we've looked at right now is we've factored binomials. So we've done things like I've got 2x squared plus 5x, and we factored, not 5x, 10x. And we factored out a 2x, and that left me with an x plus 5. Then we did the factoring by grouping. Things like I've got 2x squared plus 10x plus 15x plus 75. So then we factored out a 2x from these two terms. We factored out a 15 from these two terms. And then I got the x plus 5 and the 2x plus 15. So we've done that type of factoring. We've factored out common expressions. What we're going to do now is we're going to factor trinomials. So we're going to take a trinomial of x squared plus bx plus c. So something like x squared, well, what is this? X squared plus what? 6x. And we're going to break it down into this product of two binomials. So this right here actually belongs down here. So what I can do with these algebra tiles in this particular arrangement is I can smoosh them together to make a rectangle. So I've got my x squared in the corner, and then I arrange my x rods, and then I arrange my 8s. And within this rectangle, I can tell you this is the area. The area of the rectangle is this x squared plus 6x plus 8. That's the answer to number 4. The area of the rectangle in expanded form. What is the length of my rectangle? So what length is represented by this dimension of my algebra tile?
X squared.
The whole area is x squared. What's the length though? X. And what do each of these widths represent? 1. So 1, 1, 1, and 1. So what's the length?
X plus 4.
X plus 4. What's the width?
X plus 2.
X plus 2, because I have the 2 1s. How do I calculate the area of a rectangle?
Length by width.
Length times width. So the area is going to equal x plus 4 times x plus 2. If I expand this out, I use the distributive property. X times x,
X squared.
x times 2,
2x
x times, or 4 times x,
is 4x.
and 2 times 4,
Is
8. Collect the like terms, and how many x's do I have? 6. I have 6x squared plus 6x plus 8. So we can take this polynomial expression and we can factor it into these two factors. And there is a patterning to do this. It's not, it's not just that I picked it randomly. The only way that I can create the rectangle with these shapes is by this configuration. I could turn it to the side and have 4 and then 2 down here and my 8 going this way. But this is the only way that I'm going to be able to put it. I'm not going to be able to take this rod and put it down here because I won't have 2 more little squares to put in place, or I'll have too many extra. So there's only one way that I can make the rectangle. And making that rectangle gives me the length and the width. So that's what we're going to look at, is we're going to make a couple of rectangles. So what polynomial do I have represented with these tiles?
X squared plus 5x plus 4.
Okay. So on the next screen. X squared plus 5x plus 4. What I want you to do is I want you to arrange them into a perfect rectangle.
My fingers were just small.
What did you start off with? Which tile did you position first?
Big one.
The big one, okay. And then what did you do with the rods? Did you just start kind of guessing and checking? Put a rod here, put a rod here. What do I know that I have to do?
Have 4 rods.
Hopefully I see that I need to have one of these rods going up, because then I can put the 2 ones. Now I have a rectangular shape. Add in another rod, add in another one. And then if I add in another rod, I have to add in another one. So in order to have a situation where I have these little guys, I have to make sure I have rods pointing in both directions. That's the only way that I'm going to be able to do that. Okay, so let's go back to this page. So if we arrange this into a rectangle, we're going to sketch what our rectangle looked like. So we have the big square, and then we had 4 rods going in one direction and 1 rod going in the other.
Yeah.
So it doesn't matter how you do that. If you want, you can show 1 rod going this way, and then 4 going that way. I should be trying to make these consistent in their width. And there's my rectangle. What is the length of my rectangle? X plus 4. This is an X, and these are all 1s. So my length is X plus 4. And what's my width? X plus 1. So the polynomial in factored form, this x squared plus 5x plus 4, when I write it in factored form, will become x plus 4 times x plus 1. Area equals length times width. Okay, so let's look at class example number 2.
I'm going to check this out.
This time we have positives and negatives. So what polynomial expression is represented by these tiles?
X squared. Negative 7x.
Cool.
It's plus 12.
Plus 12. Okay, so again, I want you to try to arrange your algebra tiles to make a rectangle. Okay, so when I try to arrange my algebra tiles, from the last question, what I know is in order to put these 1s in place, I need to have 1 going this way and 1 going vertically. And that allows me to put in 1 of those. If I put another 1 here, I can put another 1. If I turn or I spin this one and I add this into the mix, I can now put 2 more. And if I put a third one down here, I can put in 2 more. Put a 4th one down here, I can put in 2 more. And then when I get to this last one, well, if I put it down here, I can only add 2. But again, if I make it going vertically, I can now put in all four. And now you have a perfect rectangle. So sketch that rectangle out in the space provided. So I had my x squared in the corner. And then I had 3 x's going in one direction. And 4 x's going in the other. Which then gave me my 12 below. What is the length of my polynomial? X plus 4. What's the width?
X plus 3.
So this polynomial, x squared minus 7x plus 12, in factor form becomes x plus 4 and x plus 3. So your homework is I want you to do questions number 2 and 3. You can take the algebra tiles home if you want, but they need to be returned back to me. Go back to this. What is the length? Not x plus 4. Because in this, these were all shaded.
Oh, it's X plus. Just subtract row. It's negative X.
So it's x minus 4 and
3.
x minus 3.
Yeah, I thought pure, right?
I thought it didn't seem right, but I'm not going to say
I
anything.
thought colored in one was positive.
Pardon?
I thought colored in one was positive.
Yeah.
It depends what you declare at the beginning. And I think at the beginning of your book, where did we have algebra tiles last time? It defined what the open ones are negative, the colored ones are positive.
Negative X.
No, because this right here, this is my negative 3. And then this right here is my negative 4. Because this is my x, and then a negative 1, negative 1, negative 1. Okay, so I'm not reading it from this end, I'm reading it from this end. Okay? There we go. So when we're trying to factor our trinomials, this x squared minus 7x plus 12, we're making it into a rectangle and we're kind of working backwards to find the length and the width of that rectangle. So when you were working on questions 2 and 3 and you were drawing the diagrams out or thinking about the algebra tiles, what is the advantage to using the algebra tile? Easier to see, it's manipulative, you can move the tiles around, you can change the direction of the tiles, you can fit them together to make that shape. What's a drawback to using the algebra tiles?
Takes a long time.
Can take a long time. What would happen if I gave you a question such as,
You don't have enough pieces.
you don't have enough pieces, or I have to put a whole bunch of kids together and like 10, 8, and 35, we're talking about 53 tiles that we now have to manipulate and try to form into a rectangle. So we start off using concrete items, using symbolic items, so that we can move into an algebraic form. And that's what we're going to do in the next part of the lesson, is we're going to try to do these symbolically or algebraically. So what we look for is we look for patterns. So what I want you to do is I want you to expand these 5 binomials and write them out in their trinomial form. So, for example, the first one's done for you. X plus 2 times x plus 4 gives me x squared plus 4x plus 2x plus 8. And then I collect the x's and I get 6x. So I'm going to give you a couple of minutes to work on that. So if we go through and we start expanding these out, what do I get when I go x squared plus, or sorry, x plus 3 times x plus 3? What do I get? I want the trinomial.
Plus 6x. Plus 9.
Okay. Colin, what do I get when I go x plus 1 times x plus 7?
7.
Pardon? Just 7x? When I multiply these two together.
Oh, x squared plus 7x plus 1x plus 7.
So what do I get when I combine the like terms?
8x.
Thank you. Kate, what do I get when I go x plus 5 times x plus 2?
X squared plus 7x plus 5.
Okay. When I go x minus 5 times x minus 2, Raylan, what did you get?
X squared minus 7x plus 10.
And Delana, x plus 8 and x minus 6.
X squared plus 2x minus 1.
If I asked you to multiply x plus 9 and x plus 2 and give me the trinomial without doing the part in between, would you be able to do that? Would you be able to give me the x squared plus something x plus something else? What's this going to be? How do I get the 18? 9 times 2. What would this be?
11.
How do you get the 11?
9 plus 2.
9 plus 2. Does that work for all the rest of them? 3 times 3, is that 9?
Yeah.
3 plus 3, is that 6?
Yeah.
1 plus 7 is 1 times 7. What was the next one? 5 times 2 is? And 5 plus 2 is? And then 5 minus 2? And negative 5 times negative 2. So all of that seems to work out. So if we follow below that, in the expansion, if I had x plus p times x plus q, and I wanted to write that as x squared plus bx plus c. So we're using straight algebra, letters here, while I fight with the extension cord. How do I use p and q to get the value of b? So how did I get this middle term? What did I do with these two? I added them together. So the value of b is p plus q. How did I get the c value? I multiplied them together. Okay? This is the basis behind factoring trinomials. Is this relationship between the b, the middle value, and c, and this p and q. Because what we're doing is we're going to be working backwards. So when we work backwards, it's trying to find out numbers that when I multiply them together, I get 7, and when I add them together, I get 8. Because that's what we're doing when we work backwards. So the next one just looks at using FOIL to show that x plus p times x plus q can be written in the form that is shown here. So if I FOIL this out, FOIL is the acronym for the distributive property, the first, the outside, the inside, and the last. I don't use FOIL very much because I want you to remember we're always distributing. FOIL doesn't work if I have a trinomial because it only works for binomials. So if I multiply x by x, I get x times q. xq, or if I put it in alphabetical order, qx. P times x will give me a px, and then p times q. Right here, I have like terms, and in a sense, I have common factors. I have an x in common, so if I divided out an x, I'd be left with a q and a p. And there's my simplified form. And there's my form where I'm showing that C is equal to P times Q, and B is equal to Q plus P. I call this a sum and product chart. In order to factor a trinomial of x squared plus bx plus c by inspection, we need to find two integers that have a product equal to the c value and a sum equal to the b value, sum and product. So in order to factor x squared plus 8x plus 12, I need to find two numbers that multiply out to 12 and add to 8. Can you think of two numbers that multiply to 12 and add to 8? 6 and 2. Okay. In order to factor x squared minus 13x plus 12, I need two numbers that multiply to 12 and add to negative 13, because there's a negative in front of that. So give me two numbers, or what do I know about these two numbers if they have to multiply to 12 and add to negative 13? They have to be two negatives, because two negatives multiplied together will give me a positive, and two negatives added together will always give me a negative. So what are my two numbers? The key to this is your multiplication facts. Those of you that know your multiplication facts quite well and quite strong, this will be an easier process. If you struggle with thinking of the numbers that can multiply out to 12 or the numbers that can multiply out to 15, it's going to be a longer process. So we're going to practice. In this chart, you need to complete the tables to find two numbers that have the sum and the product that are given. For example, two numbers that have a sum of 12, meaning they add to 12, and a product of 20, 10 and 2. 10 times 2 is 20, 10 plus 2 is 12. So two numbers that multiply to give me 20 and add to give me 9.
4 and 5.
4 and 5. Does it matter if I write 4 and 5 or 5 and 4? Absolutely not. Finish the chart for me. Okay, so let's look at the rest of my chart. Two numbers that have a sum of 4 and a product of 4. 2 and 2. Sum of negative 9 and a product of 18. Thank you. A sum of negative 15 and a product of 14. Negative 14 and negative 1. These ones are always going to mess you up, because we never remember, or the product that we tend to forget the most is the product of the number times 1. And we tend to use it a lot when we're factoring trinomials. A product of negative 6 and a sum of negative 1. Negative 3 and 2. How did you figure that one out, Tyrone?
I don't know. Actually, I just kind of thought that. I thought if the sum is negative 1, then it has to be, the negative has to be a larger, but only by 1. And then this two that work together is negative 3 and 2.
Okay. So then when I'm figuring out my products, which could be 3 and 2 and 6 and 1, when I'm figuring out that sum, I'm actually finding the difference between these two numbers. And to make it a negative 1, I make, like Tyrone said, this number has to be the negative in order for this to be the negative. Okay, so then two numbers that multiply to negative 15 and add to 2.
Negative 3 and 5.
So this is the opposite this time. The bigger number has to be the positive one. Okay, and two numbers that multiply to 48 and add to negative 26.
Negative 24.
So negative 24 and negative 2. Patterns that you may have noticed. When my product is positive, so those were this first column and these two. When I have a positive product, my integers have to have the same sign. Either they're both positive or they're both negative. How do I know when they're both negative?
The sum has to be.
When the sum is negative. So when the sum is negative and the product is positive, my integers have to be negative. When the product is negative, such as in these two, it means that one of my integers has to be negative. And then from there, what it means is instead of adding these two numbers together, in a sense, I'm subtracting them. So in these ones, I'd add 12, 9, 4, negative 9, negative 15, negative 26. But in this case here, when I'm just looking at the numbers, if I ignore the idea of negatives, because sometimes that can trip me up, and I just think about, well, I need two numbers that multiply to 6, and this time I'm going to find the difference to be 1. So 3 and 2, the difference is 1. 6 and 1, the difference is 5. If I go into my 15, I have 15 and 1 and 5 and 3. This difference would be 14. This difference would be 2. To get the positive 2, I make the 5 positive, and I let the 3 become negative. So what we're going to look at for the first examples, for the first examples, is just what happens if I keep everything positive. We're going to work with positives before we start throwing these negatives at you. So we're going to look at positive products. I would recommend using sum and product charts to help you organize your information. Sum and product charts will come in handy because we're not going to stay at just factoring these types of trinomials. The trinomials are going to get harder, and we're going to do things like we're going to put numbers in front of the x squareds and see how that changes things. So to start off with, my sum and product chart. What would my sum be in this trinomial? 8, and the product? So two numbers that multiply to 8, two numbers that add to 8 and multiply to 12. 6 and 2. So how would I write my binomials?
X plus 6 and X plus.
Good. X plus 6 and X plus 2. So if I look at B, sum and product chart, what would the sum be?
13,
And the product?
12,
So two numbers that multiply to 12 and add to 13. So then what would my binomials look like?
X plus 12. X plus 1.
Could I write it as x plus 1 times x plus 12? Yeah. Okay. If I do C, sum and product chart again. What's my sum?
negative 13,
And what's my product?
12,
So this time two numbers that multiply to 12 and add to negative 13
be negative 12.
be negative 12 and negative 1. So it's similar to B, except that my two factors are negative. So what would my binomials look like this time?
X minus 12 and X minus 1.
Good. Okay, do the next three. Okay, D. My sum and product chart would be a sum of negative 11 and a product of 10. So two numbers that multiply to 10 and add to negative 11. Negative 10 and negative 1. So my two binomials would be
X minus 10 times X minus 1. Or A, that's it.
So this time I'd use A's. Okay, if I look at E, Sum and product chart would be two numbers that multiply to 4 and add to 3. Can you give me two numbers that multiply to 4 and add to 3? No.
It's not possible.
There we go. We say it's not possible. Do not write that it's impossible though, because this can actually be solved. It's not pretty. We don't learn about it for a while, but this is possible. It's just at your stage, it's not possible with what you know. Okay, so it's not possible to solve in this method. And the last one, my sum is 27 and my product is 50. So what are my two numbers?
25 and
So what would be my two binomials?
X plus 25 and X plus 2.
Okay, so take a look at 6a. Factor these polynomial expressions by first taking out a common factor. So I have 4x squared minus 32x plus 48. What is common to all three terms? 4. So if I factor a 4 out, what would I get?
X squared.
Plus 12. Now I go to my sum and my product chart. My sum is negative 8. My product is 12. Two numbers that multiply to 12 and add to negative 8. So when I write it this time, that 4 still stays. So that 4 will still come in front of my first binomial, which would be what?
X minus 6.
X minus 6. And what would be my next binomial?
minus 2.
Good. But that 4 doesn't disappear. It still stays with the question. Because if I work up, so if I expand this out by removing the brackets using the distributive property, I need to get this original expression. So don't forget about the number that you factor out if you're factoring out that common factor. What can I factor out of 3x cubed plus 21x squared plus 30x?
3x.
And if I factor out a 3x, what am I left with?
3x squared plus 7x plus 10.
So in my sum and product chart, I have to add to 10, or sorry, add to 7 and multiply to 10.
5 and
5 and 2. So the 3x will stay, and then what will I have?
2. X plus 5. X plus 2.
X plus 5 and x plus 2. So in this example, we had two steps to the process of factoring the trinomial. When you are asked to factor a polynomial expression, it means keep factoring until you can factor no more. So factor completely. So if you just see the instruction factor, it still means factor completely. It means remove a greatest common factor. Okay? Grade 11s were working on a quiz, and one of the questions, I think, when they factored it, they got this. And most of them, actually I think all except for maybe one, got 1.5 marks because this is not factored completely. What can I do right here? I can factor out a 2. So I can take that 2 out, and then the x minus 6 I can just throw to the end, or I could throw it in between. The 2 we always bring out in front. So that constant or that monomial factor always comes to the front of our product. So when you're asked to factor, it means to factor completely. Check your factors, or check your factors that you get and make sure you can't factor them. At this point in time, you won't be able to factor them anymore. But this factor that you took out originally, the 4 or the 3x, needs to stay in at each point. So the questions that I want you to work on are questions 7 and 8. 12